Hi, this is the introduction to Lab 11, the vapor pressure of water using the Clausius-Clapeyron equation. And what we're going to do with the Clausius-Clapeyron equation is come up with a value for the enthalpy of vaporization for water. So, you know that vapor pressure of a liquid increases with temperature. Well, it's not a straight line relationship. The vapor pressure of a liquid is proportional to e to the power minus delta H of vaporization over RT. Definitely not a straight line. However, the Clausius-Clapeyron equation, which takes this relationship and looks at it at two different temperatures, giving two different vapor pressures. If you look at the Clausius-Clapeyron equation very carefully, you realize, if I plotted vapor pressure versus 1 over absolute temperature, I'd get a straight line. And the slope of that would be minus delta H of vaporization. So in this experiment, you basically end up taking or figuring out vapor pressures for water at various temperatures, and then making a sort of straight line plot. Okay, so the experimental setup is fairly simple to do this. Great big beaker full of water, and thermometer, of course, back here. But here we have something rather unusual or interesting. We've got a small 10 ml beaker, graduated cylinder with about a 4 milliliter bubble of air. And that is suspended by some wires in this beaker. So at room temperature, the air and water vapor bubble is about 4 milliliters. Well, what we do now is turn on the heat so that the water surrounding the little graduated cylinder heats up to about 70 degrees. And as the water heats up, the amount of vapor in the bubble, water vapor in the bubble, also increases because the vapor pressure of water increases with temperature. And of course, you're also heating the gas, so this bubble of air grows larger in volume, and you end up having the graduated cylinder sort of rise up as this bubble increases. Get to about 70 degrees, turn off the heat, start throwing some ice in to gradually cool down the water, and all the while taking readings of the volume of the bubble. At some point, we want to know, well, in this bubble that has air and water vapor, just how much air did we have? So we take a lot of ice, more than this, throw it in the water to chill everything down to as close to 0 as possible. At 0 Celsius, well, vapor pressure of water is pretty close to 0, so whatever the bubble is at 0 C, whatever volume it has, then that will enable us to figure out how many moles of air, how much air did we have in this bubble. Okay, that's the end of the experimental description. You will get another video explaining the calculations, and you'll also get a data set.
Yeah. All right. So as always, I want you to record this data into your own data sheet and pen. If for some reason you don't have a lab manual, just write it onto a piece of paper. So we took only one pressure, and that's what we normally do for this lab. So we're just going to assume the pressure stays the same throughout the lab. And then over here we have your volume in milliliters recorded to 1 digit after the decimal. It's actually normally pretty tough to get that reading because you're reading through the beaker to the graduated cylinder, and the graduated cylinder is hanging upside down, so it's a little challenging. And for your temperature, you would take the temperature every 5 degrees until 50, and then get something below 5 degrees, and I've given you 1 degrees down here as your temperature. All right, so now depending on what version of the lab manual you have, I think when they updated it, they forgot to make this correction. Right over here, it says R 6.237 times 10 to the fourth. They wrote it as 104. It should have been 10 to the fourth. But what I'm going to tell you is you don't actually need that value. I recommend doing it in ATM. And when you watch the calculation video, you're going to see me calculate out in ATM. Over here where it says N air, so that is solving PV equals nRT for N. For P, you're using PATM from the barometer, so that is the pressure of the barometer. I recommend you do it in ATM, and I recommend you use your regular R, 0.0821 here. And the temperature right here would be the lowest temperature you have in Kelvin. So for us in our data set, it's 1 degree Celsius, and then you're going to convert that into ATM. Or I'm sorry, convert that into Kelvin. All right. So next up, you're going to be crunching out this data in an Excel or another spreadsheet. Google Sheets is free, it's online. So if you don't have Excel, that will work for you. Then you need the slope of your graph. And you are going to find delta H of vaporization for that, and the video takes you through how to do that. Percent deviation, this is your value minus the accepted value divided by the accepted value. Again, the video is going to take you through all of that. So let me just show you where you're going to get all of that from. It's going to be on our Canvas site. Where is that Canvas site? Just a sec to pull up the Canvas site. There we are. Oops, wrong Canvas site. All right. So here, if you go to your lab notes, here is where you're going to find the class data. And soon you'll be finding the page that I was just showing you on my iPad. But in the actual lab section, there it is. Here's where you're going to get information about Lab 12. So sample data sheet and the student Excel sheet. So sample data sheet right here, this goes right along with that video. So I'm going to show you how to set this up. And again, this is the data sheet from the video. So it's not your numbers, they're different numbers, but it takes you along how to do everything. And then the student Excel sheet right here. This is set up so you can go ahead and start plugging in. You should also be able to open this in Google Sheets if you're using Google Sheets. My recommendation when you're watching the calculation video is go right along with that calculation. So in other words, the calculation says enter this, and I show you how to do it. Hit pause, flip back to this page, and go ahead and enter it. Then go back to that video, because the video is showing you what formulas to enter into each of these cells, and that's going to be tough to remember after you get through a 40-minute video. And the calculations link is right here. It's also in the video section. And again, it takes you to a Google Drive site, and it should open right away. If it doesn't, try a different browser. And let's see. And I think that's all I wanted to share with you about this lab. So any questions on this Lab 12? All right, so let me just go back to our upcoming due dates. So you have some time to do this lab, but since we don't have a lab tonight, you are more than welcome to just stay, work on it, and get it done. So I have made it due on Wednesday the 13th, so that is a week and a half away. But there's no reason that you can't just get it done now and then not have to worry about it.